Welcome to my YouTube channel where I take you through the length and breadth of research methodology, making it very easy for even a novice to understand. I take it through step by step, precept upon precept, chronologically, so that you will follow. You will enjoy it, so that you appreciate what research methodology is. Today, I am talking on assumption test. Very important. Your entire work, the value which you can render to the scientific world or to the academic world is being rated by the assumption test. The acceptability of your research work is based on assumption test. So that's what I'm talking about. Very, very important. Most students, they do their research work without assumption test. And then when you do without research work, it's assumed to be a guesswork. But I don't think that is so. Maybe because you don't know how to go about research, assumption test, going about carrying out assumption test. So I'm going to tell you three things here. One, the importance of assumption test. Two, what is assumption test? And three, what are the types of assumption tests? What types of assumption tests we have? We'll go quickly to what I have on the screen here now. So objective of this study, this very lecture, is for you to understand what assumption test is, what types of assumption tests are, what are the types of assumption tests, and of course the relevance, the importance of assumption tests. I will start from the bottom, the importance of assumption test. Now, assumption test, in understanding it, you should understand that whatever outcome that comes out of your analysis in any of your research work, a scientific proof must be given to the readers so as to show that such outcome, such findings, and recommendation out thereafter are not mere assumption or just guesswork. You suffered yourself to carry out work. You came out with an analysis, an outcome from the analysis, and you made recommendation. There is nothing to prove that all that you have said scientifically, nothing to prove that this is why you said so. This is why you said so. This is your backing. Now, you came up with a work that has to do with dependent variable, independent variable, maybe moderating variable in extreme cases, suppressive variable. How do the reader know that this is actually the independent variable scientifically? How will the reader know that this is the dependent variable scientifically? Nothing. If you don't show, then how will he know? There should be tests that must be carried out to show that this is the independent variable, this is the dependent variable. Again, you said in a work, population is X, sample is X minus 4, for instance. How are we sure that X minus 4 can adequately represent X? And how did you get your sample size? You can use any method. Terra-Yeoman can be used. A table can be used. Crusoe and Morgan table of 1970 can be used. You can use any form to get your sample size. When you do that, then you should carry out certain tests when you must have gotten your sample size to show that this sample size can adequately represent the opinion of the general population. You just have to do that. Otherwise, you are playing. How do we know that your dependent variable has a normal distribution? Because if your dependent variable is not normally distributed, it will give us a spurious answer. The outcome of the analysis will be spurious, will be biased. How do we know that your independent variable, the dimensions, are not closely related? If you don't prove these things, then your work is just mere academic exercise. So this very study is important for you to sit back and listen and know why you should carry out this analysis. You carry out this test. They call assumption test. You went ahead and carried out a regression analysis, hypothesis. A regression analysis cannot be carried out if there is no assumption test that the variables are linearly correlated. You must prove it. Once you put this on the table, then there is a proof that yes, this work has, this is the outcome of the regression analysis. It will be believed, it will be accepted scientific because you had already proven it, and all that and all that. So assumption tests are tests that are carried out prior to the analysis. You must have to carry out these tests. They're called assumption tests. So I've told you the importance. Now let me define what assumption test is. These are my definition. The first, I have three definitions for you. Three. The first one is assumption test could be defined as a pre-test that is conducted to determine whether a scientific conclusion can be drawn from the post-test. So an assumption test is the one that is conducted to determine whether the person who has read it, the person who has gone through your work, to even the recommendation, whether it can draw out a scientific conclusion from your work. It is the assumption test that gives him that backing. If there are no assumption tests, I tell you, no scientist will want to reckon with work that has no assumption test. There's nothing to prove on your work that yes, you carried out a scientific work. There's nothing to prove. So number one, you have to prove that a scientific conclusion can be drawn from your work. Number two definition of assumption test is that an assumption test is the scientific proof shown that each stage prior to the analysis where each stage was scientific and met the generally accepted conditions to carry out the analysis. You started your work. If it is in a survey design, that's a survey design. That means that you administer some questionnaire, particularly if it's longitudinal. Now you give it has a survey design anyway. Now, if you give out you administer some questionnaires, from there you got them back, you carried out the data cleaning, you carried out the univariate analysis and all that. Then you drew up hypotheses, you analyze them, you got the findings, you gave a recommendation and all that, or you did a discussion and did the recommendation. In all of these stages, how do we know that each of these stages should be believed in? So it is assumption test that gives us that backing, that gives us that scientific strength to believe in our work. So prior to the analysis, scientific tests should be conducted on each stage to show that these analysis or each of them, each of the stage are accepted conditions to carry out the analysis. You had already met those conditions prior to the analysis. The third definition of assumption test is a simple one. It's a simple one. It is the testing the tester test. That's how I define it. Testing the tester test. You want to carry out tests. There's a tool you use to carry out tests. You have to test that tool, whether it has the qualities, the nitty-gritty qualifications to carry out the test. That's how it is in assumption test. You carried out a work, the entire work, research work. How do we know that each of those stages where they went through scientific processes? So these assumption tests are those things that will now test your work to say that yes, the outcomes are correct. So you must carry out these assumption tests. So these are the three definitions I have for you. let's look at the types of assumption tests. And I have 11 types of assumption tests. These 11 types are very necessary. They are necessary. There are more than that. You can carry out as many as you want. But these ones are basic. They are very necessary. Number one is the one sample t-test. One sample t-test tend to prove that their sample can adequately represent the opinion of the population. You don't just say the sample is X, and then you tell me the population is Y. And then how do I know that X can represent Y? It is this one sample t-test that will prove to be that yes. And of course, the output will tell us about the mean. The mean must be very close. If the mean are too dispersed, then it will not. The second one is second test is what I call the KMO test. KMO means Kaiser Meyer Oakland test. This test confirms to you, the user, that there are variables in your data. There are variables in your data. So, and of course, the output must be 60%, 0.6. If it is less than 0.6, then you begin to have some spurious outcomes, some biased outcomes, may not be trusted. Number three, the third assumption test is simply called the Bartlett test. A man called Maurice Stevenson Bartlett was the man who came up with this concept. He said that this test is conducted to confirm the rationality, the rotationality and the correlation matrix of the entire data. The p-value should be less than 0.05 in that test. When you use SPSS, the Scientific Package for Social Science, SPSS, it gives you all this. And SPSS is best for primary data. When you're using primary data, it's super for SPSS. Now, number four, the fourth test. The fourth test is the Lee-Krubak alpha coefficient test, simply called the Krubak alpha or the reliability test. The percentage of the output should be 70%, which is 0.7. If it is less than 0.7, then it cannot be trusted in its consistency in use by other researchers when it is used as a secondary data. Now, this test confirms the reliability of the entire data. So it will not be reliable if it is less than 0.7. From 0.7, fine. 90%, fine. 80%, fine. The fourth one is the factor analysis, or the factorization test, which is the factor analysis. The factor analysis test groups your variables. It puts your variable into those dimensions and measures for you on its own. SPSS is very good at that. When you use SPSS, it will just do the factor analysis for you, and super. You begin to see your variables in, you begin to see your data in variables, in groupings. The sixth test is the causality test. Causality test is where you get the dependent variable and independent variable. As I told you earlier, how do I know that your work, this is the dependent variable, this is the independent variable? It is this very test, causality test, that tells me that this is the dependent variable. And you see the p-value. P-value tells us, yes, this one is caused by this. This one is not caused by this. This one is dependent by this. This one is not dependent by this. You must carry out that assumption test. Show us that this is independent variable. This is the dependent variable. This causality test we use E-views to do it, not SPSS. But if you want to use SPSS, that's the way we do it. It's we go through a rigorous exercise to conclude that this is dependent variable, this is independent variable. But otherwise, when you carry out the factor analysis test, you can just take all those after you must have gone through the transformation of the variables. When you transform them to variables, you now carry the variables to the EViews, and wholesomely, as you put them there, the outcome will tell you, the output will tell you which one is dependent variable, which one is independent variable. That is the sixth variable. The seventh, that is the sixth assumption test, sorry. The seventh assumption test is what we can call the normality test. The dependent variable must be tested to know whether it is normally distributed. Any dependent variable that is not normally distributed will give you a spurious answer. It will give you a biased answer. And inside this test, a number of things will be seen. You see the skew test, the outliers, the cortices. You see the Kolmogorov, Smirnov, Kolmogorov-Smirnov, and the Shapiro-Wilk test. You will see all of them are embedded in one test. This thing will prove to you that this variable is normally distributed. That is the seventh test. The eighth test has to do with the multi-correlationality test of the dependent variable. This confirms that the measures of the dependent variables are not closely related. If your measures of your dependent variable are dependent variable are very correlated, are very closely related, then they are good. But if they are not closely related, then you have spurious answers. Dependent variables should be closely related. Then conversely, the ninth test has to do with the non-multi-correlationality test of the dimensions of your independent variable. This confirms that the dimensions are not closely related, that they are good. If your measure, their dimensions are closely related, then it is as good as one variable. All of them are just one. They must have disparity, maybe 0.2, 0.3 correlation, even 0 point something, no problem. But once it is up to 5.5, 0.6, then they are becoming too close. If you say up to 0.9, oh, that is as good as one variable. So the farther they are in their closeness, the better for a very sound and trustable outcome. That is the ninth one. The 10th assumption test has to do with unit test. Unit test of all of them, of all the weather measures and the measure of the dimensions have to be considered. The unit test checks out for the stability of the variables. Are the variables trusted? Are they the ones that can swindle, that are very inconsistent? Are they consistent? Are they very stable? So this test confirms the stationarity of each variable to avoid spurious correlation and biased outcomes. If the variables, those dimensions and measures are not unitary, that they are not they don't pass the unit test. They don't pass the unit test. Then they are not stationary. Then they will have a spurious outcome. You can imagine when you didn't carry out this test, you just did your work. And then those of us that know about this kind of test will not believe in your work. We just, how do I know that this one is the dependent variable? How do I know that this one is unitary? It is stationary. How do I know that these dimensions and measures are stationary? You just have to prove. When you prove them, they will begin to believe in your work. What proves your work to be sound is assumption test. The 11th one, and the last one, of course, is the bound test. The bound test tells us the longevity, how short or how long these variables or dimensions and measures will last in their relationship. Is it the one, in 2 minutes? Okay, fine. They are correct today. Tomorrow, see them ding-donging, they see them going haywire, they're going them falling apart. So this test confirms the stability of the variables, whether the correlation between the variables will be consistent or not in the long or short term. So this is the reason why we do it. So you want me to trust your work. You want the readers to trust your work, to take your recommendation serious. Then you also carry out assumption test. Assumption test is very important in any scientific work to prove that it was not just a guesswork. Wow. I want you to take note something now. Note, please, that there are other tests you could carry out to prove that your outcomes were not a product of mere assumption. There are other ones, aside from the 11 I've given to you. And it's not compulsory that you put all the 11, but the more assumption you put, the more proofs, the more acceptability your work is, or the more acceptable your work is, rather. So if you didn't put any assumption test, maybe Kroback alpha alone, Kroback alpha does not, it is just one among many. Kroback alpha only proves that your data is reliable. But that's not all. How do I know that this one is the dependent variable, this one is independent variable? So you just have to do that. How do I know that? How do I know that? Yes, you carried out other tests like the bound test. How do I know? How do I know that this test is stationary? These variables are stationary. So you must have to carry out this test. I want to say thank you so very much. I am Dr. Abel Simeon. I am the Managing Director of Amom Consulting Limited. I am also a doctoral research fellow at the Corporate Institute of Strategic Research. I am also the Director of Strategic Planning and Research at the Institute of Professional Industrialist and Management Development. Well, in this business of empirical research work, well, I have several years of experience. So if you have any question to ask, please send those questions to my WhatsApp line as you see it on the screen, +1505232466646. That's my WhatsApp line. Or you can send it to my brother Abel1@gmail.com. Or you can even send it to Abel Simeon, abel.simeon at IPIMD, that is the Institute of Professional Management, Industrial Management Development.org. Send it there. Or Abel Simeon at CSR, that means Corporate Institute of Strategic Research.org.ng. When you send them there, I will get your questions, and of course, we will discuss them. Thank you so very much. See you in my next video.